There are small things which you require, say a balloon, a plastic pen, and small scraps of paper. You would have done this many times. So we will do it again and just understand what is this electricity or what is this static charges. Normally when we play during your small days, small ages, what you used to do normally, you'll take a comb or a scale, plastic scale, whatever you have, rub it on your head or your hair. You try to rub it fast 3-4 times and then keep it near bits of paper. It will automatically attract like this. You should have observed this experiment many times. So whenever you do that, there's no need to have any other additional charges here. You just rub your hair and you allow the scale near the bits of paper. It will automatically get attracted without rubbing it on your hair. If you keep it near the bits of paper, nothing is going to happen. So what's going on here? We manually try to move all the electrons from one material to another. In the example I gave you, you are moving electrons from your hair towards the paper which is there. So what you have to do is, you will be able to move electrons from the ruler towards the paper. Steffi Margaret, I think you are in. See if your doubts are cleared and let me know. Here, what is electricity? Simple definition, it is just movement of electrons, or we tell it as rate of change, movement of charges. So in 1 minute, how many electrons are able to move? If you are able to do that, that is nothing but electricity. Steffi, if you're online, you can tell me if your doubts are cleared. So one definition for electricity is as simple as that. It is only movement of charges. Steffi, is it clear? Okay. Mic is off. We will ask during the discussion session. Second doubt she asked me was about drift velocity. So what is drift velocity is? You should remember this. Two like charges will always repel. See, positive and negative only will get attracted. So electrons, as you are aware, are electrically negative. So electrons are negatively charged. So when we allow protons, which are positively charged, to move towards the electrons, current always moves from positive direction towards your negative direction. Electrons are negative. Keep that in mind. So what is drift velocity is? You will be allowing electrons to move. So electrons should move towards the protons. First point. Second point, current will move from the positive charge towards your negative charge. So drift velocity is the speed with which the electrons are moving opposite to the direction of electric field. Electric field is from positive to negative. Electrons are moving from negative side towards your positive side. So drift velocity is the velocity with which electrons are drifted, or electrons are moving away from a direction which is opposite to your electric field. So these two things are the doubts which were asked. I asked you a question yesterday regarding what is the mass of a difference between two electrodes. One electrode is positive, the other electrode is negative. So you will have some difference in the potential. So if you want the cell to be connected, cell is connected in the sense current can flow. So it can be an open circuit or it can be a closed circuit. Open means current will not flow. Closed circuit means current can flow. So here, electromotive force, or in short what we call as EMF, is the potential difference between two electrodes of a cell. Cell has two lines. Bigger line is positive, the smaller line is negative. So the potential difference between those two electrodes, when, underline this or keep this fixed in your mind, no current is drawn from the cell. No current is drawn means they are not connected. So when they are not connected, what is the maximum potential difference between the two electrodes? We call it as the EMF. I'm repeating it again. EMF, or electromotive force, it is the maximum potential difference between the two electrodes of a cell when no current is drawn from the cell. or the cell should be an open circuit. So that is the case when electromotive force comes into picture. So I think we are clear with this. EMF should be potential difference between two electrodes when no current, this is the important point, should be drawn from the cell. Now there's a comparison between EMF, that is electromotive force, and PD. PD is nothing but your potential difference. So we will study it under a differentiation table or a comparison table. So first side you have EMF. Full form you are clear. It is electromotive force. Whenever you talk about electromotive force, keep in mind no current should be drawn from the cell. So this EMF first difference is, it is the maximum potential difference between the two electrodes of the cell when no current is joined from the cell. So here no current is joined means the current circuit has to be open. So the same definition of your EMF can be written as the first difference. Under potential difference, it is the difference of potential between any 2 points in a closed circuit. So here it has to be an open circuit, here it has to be a closed circuit. Second difference, EMF is independent of the resistance. Resistance does not have any impact on your EMF, whereas in potential difference, resistance will be proportional. So first difference, EMF is in open circuit, potential difference is in closed circuit. Second one, it is independent of resistance. Here it is proportional to your resistance. Third, EMF is used only for the source, whereas potential difference is measured between any 2 points. Here only for source we can do only 1 point, whereas here you can do it for 2 points. The last difference, EMF is greater than the potential difference between any 2 points in the circuit. It's the opposite. Potential difference should be greater than the EMF. Learn this up very quickly. First difference in EMF, keep in mind it is for an open circuit. That means positive and negative are not connected. The second difference here is for potential difference, it is only for a closed circuit. Here, independent of resistance, proportional to the resistance. EMF is only for source, that is only for 1 point, whereas potential difference, it is for 2 points in any circuit. Last difference, EMF will be lesser than the potential, or other words, potential difference should be greater than the EMF. That is what you are writing. The same thing you can interchange. When you write it for EMF, just mention EMF is less than the potential. Here you write potential is greater than the EMF. So this is a 2-mark question. 4 points, list it in your mind. First one under EMF, open circuit. Second one, independent of resistance. Only for 1 point is the third. The last one, it should be lesser than the potential difference. So once you know what is the difference between EMF and your potential difference, we'll go on to the next topic, color coding. This is a very interesting thing to learn. I want you to have a paper, pen in your hand. So we'll try working out a few things. A resistor is nothing but you will have a small, very small, say 0.1 centimeter. That centimeter will be the length of the resistor. You can see my pointer pointing, that is called as a resistor. Now how to write what is the value for this? Very small. We will not be able to identify or write any numbers on this value. You can just imagine woolen thread you have. So that will be the size, or a little more easier for you to understand. Your mobile charger cable thickness is there, no? That will be the thickness of the resistor. So on that, if I'm going to write 4 numbers, it will not be that visible to me. So we have a method to identify what is the value for this resistance. Observe clearly, there will be 4 lines. Okay, one side there will be 3 lines which are marked. Towards the other end, there will be only 1 line. So wherever 3 lines are there, we start from that end. Yeah. So here, if you are writing the number, we have to remember one code word. easy for us to always remember when we have something related like a synonym. So here I want you to remember this. B.B. Roy of Great Britain had a very good wife. Tell it in your mind once or tell it a little loudly and try it out. B.B. Roy of Great Britain, in your mind, don't disturb the class, has a very good wife. It's easy to remember. So first B here stands for black. Second one stands for brown. In Roy, R stands for red. So here, leave off. G stands for green here. B stands for blue. V stands for violet. Good wife, no? There. G stands for gray and W stands for white. You can see these colors here. B.B. Roy, whichever is in capital letters should indicate a color. So first color will be black. Second B will be brown. R will be red. O will be orange. Y will be yellow. Next capital letter here is G. So that is green. Here you have blue. Next capital letter is B. Violet, gray, and white. So you can write down these colors like this. After you write it, just give numbering. Remember, we are not starting from 1. We have to start it from 0. So when you start from 0, you give numbers, it will come up to 9. There are 10 colors, but since we are starting it from 0, it will come up to 9 colors. Clear? Micromax Q386, please mute your phone. Anusha, mute your phone. Okay. So here, keep this sentence in your mind. Give numbering like this. The fourth column will only be for 3 colors which will be there. One is gold, second one will be silver, or sometimes there will be no color which is found. So if you have a gold color here, this will be tolerance of 5%. Keep in mind, gold means 5%. If it's silver, it should be 10%. If there is no band, you don't see any color here, then the tolerance should be 20%. So the fourth line will only have 3 values. If in gold, it should be 5%. If in silver, it should be 10%. If there's no color at all, it should be 20%. So this is the fourth line. Now forget about this. We'll come to the first 3 lines. Now you have to write down all these colors in the order and write down these numbers. First line here, it is written as B. That is denoting your brown color. Straight to brown, what is the number? We write it as 1. So whatever is the color here, brown, so I have written 1 here. The second color is violet. Violet, what is your number? It has to be 7. So what you should do is first 2 rings. Whatever is the corresponding number to the color, those values should be written. Brown here, so I've written it as 1. Violet here, so we've written it as 7. Second example, green. Table C, what is the number for green? It is 5. Second line is red. What is the number for red? So you can see it is 2. Third example, brown and violet. So brown is 1, violet is 7. So you have to just check it like this. First 2 rings, whatever is the number, same way you can write the color. But for the third ring, what you should do is, this is common, into 10 should be written for everything. Third ring value should be written on the power. For example, if it is black, it will be 10 to the power of 0. If it is orange, it will be 10 to the power of 3. If it is violet, it will be 10 to the power of 7. So first 2 rings is just the number. The third ring, whatever is the number, will be into 10 to the power of that number. I think I am clear for you. Check the second example. You have blue here. So what we should write into 10 to the power of, what is the number for blue? It is 6. So you will write it as 10 to the power of 6. Third example, black. What is the number for black? You write it as 0. So this is how we have to write the numbers for your resistances. For those who have joined late, I'll brief it again. You'll have 4 rings. First ring and second ring, directly we write the numbers. If it is red and orange, I will write it as 23. If it is yellow and blue, I will write it as 46. If it is black and brown, you will write it as 0 and 1. Third ring should be raised to the power of 10. So here, third ring value is black, means 10 to the power of 0. If it is violet, 10 to the power of 7. If it is red, 10 to the power of 2. Fourth ring, only 3 values. Gold means 5%, silver means 10%. If there's no color, it means you have to write it as 20%. So here you have to interpret the value. Brown, violet, black. What does the value means? 17 into 10 to the power of 0. 10 to the power of 0 is 1. So 17 into 1 will give you 17. And since it's gold, tolerance is plus or minus 5%. See the second example, green, red and blue. So green here is 5, red is 2, blue is 6. So 52 into 10 to the power of 6. Silver color is there, so plus or minus 10%. See the third example, the same on top, brown, violet and black. So it will be 17 into 10 to the power of 0. But the fourth line, there's no color. That indicates the tolerance is going to be 20%. So keep the statement in mind. B.B. Roy of Great Britain has a very good wife. Capital letters indicate your colors. Quickly recall, B for black, brown, red, orange, yellow, green, blue, violet, gray and white. So this color coding is very important as you go on to your higher classes also. This color coding will be needed for you to write the value of your resistances. So you can see, I'll share the slide with you after the class. First 2 rings from the end gives the 2 significance. Third ring indicates the decimal multiplier. Decimal multiplier means into 10 to the power of what? Last ring indicates the tolerance. Tolerance are only 3. So today's assignment will be depending on the color resistance. I'll give you a few values. I want you to find out what is the value for that color and let me know. So we'll move on to the next topic. This is another way for color coding. Instead of rings, we will have a dot. So color of the body will give you the first significant figure. So color of this resistance is yellow. So for yellow, what is the number? That will be the first digit. Color of the end. See these 2 sides you have red. The first number will be the color of the body. The second number will be the color of the ends. Color of the dot will give you the decimal multiplier. You can see blue here. So that will give you the value of what you are writing on top. When you look at a resistance, if you don't have rings, then the color of the body is the first number. Color of the end is the second number. Color of the dot will be your third number. And the fourth number, 1 ring will be there. That will give you the value for resistance. So here it is in gold. So you have yellow body, red ends, blue dot, and the ring is in gold. So your value for yellow will be 4 and the value for red will be 2. So that is 42 into 10 to the power of, you have a blue dot. So that will be 6. 42 into 10 to the power of 6. Gold is there. So that will give you plus or minus 5%. That is how you have to find the resistance. One method, 4 rings. Second method, only 1 ring will be there. In that case, see the color of the body for the first number, color of the end for the second number, color of the dot for the third number, and the color of the ring for the fourth number. You can play this as a game. It will be easy for you to remember also. Statement, keep in mind, B.B. Roy of Great Britain has a very good wife. So that is how you have to check. Now we were learning about series combination and parallel combination. First class we did. So I told you end to end it has to connect. We saw with 2 resistors. I told you we can connect n number of resistors. I've done it for 3. So only one end is interconnected, one after the other. How you see coaches in a train, one behind the other, they are connected. That is an example for series combination. Dots indicate the two ends of your series resistor. So if you take the effective resistance, we have to just add. R will be equal to R1 plus R2 plus R3. If there are two more resistors, plus R4 plus R5. That is the way you have to check. And the next thing we have to do is parallel resistance you are going to see. So when you see about parallel resistance, it both the ends of your resistor will be connected together. Just check here. See two dots, both the ends are connected between R1 and R2. Same way here also, both the ends are connected between R2 and R3. So one end to one end, if you connect, that will be series. One end is left free, only one end is connected. This side also, only one end is connected, that is series. Both the ends, if we connect, that will be your parallel combination. So in parallel, effective resistance is reciprocal. 1 by R will be equal to 1 by R1 divided by 1 by R2 plus 1 by R3. What you have to do is, if it is series combination, you can directly add R1 plus R2 plus R3. If it is parallel combination, you have to just Micromax Q mic, just mute. That's why I told you, please put your names. It will be easy for us to identify. So here, series means it's end to end. Parallel means both the ends have to be connected. First class, I did this derivation, effective resistance of two resistors connected in series. So we got Rs is equal to R1 plus R2. Today we will do what is the expression for resistance of two resistors connected in parallel. Please observe clearly. You have any doubts? I told you the option raise hand. So if you raise hand, I'll pause here and clear your doubts and we'll continue. Just see the diagram. Two resistors, R1 and R2. You can see both the ends are connected here. So when both the ends are connected, automatically you should be clear. It has to be a parallel combination. I is your total current. To the resistor R1, I1 is the first current. To the resistor R2, your current is splitting into I2. So main current is I. Branch currents, how you have a tree, you'll have the stem of the tree, then it branches into the different branches. The same way, main current is splitting here, so we call these as branch currents. For resistor R1, current is I1. For resistor R2, current is I2. Always when we draw diagrams like this, if you have to indicate direction, arrow mark is important. So as current is moving from the positive terminal, it's moving towards R1 and towards R2. Finally, it is coming out in this direction. This is parallel combination. R1 and R2 can be replaced by a single resistor. That single resistor is denoted by RP. P stands for parallel. Last derivation, RS we wrote because it is series. Since this is parallel, we have to write it as RP. Again, the total current will be I here, potential will be V. Here also your potential will be V. Now one current I is splitting up into two, that is I1 and I2. So what will be the total current? I should be equal to I1 plus I2. That is what you're writing here. See, before you write your notes, these statements are what I want you to write it in your paper now as you're listening. You have to describe the diagram so that what you will write is you're considering two resistors R1 and R2 which are connected in parallel as shown in figure. First point. Second point, the total current is I. Third point, I1 is the current across R1 and I2 is the current across R2. Fourth point, potential is denoted by the symbol V. So after writing these four points only, we will start with this. So these points you can write down. I'll repeat it. You're considering two resistors R1 and R2 which are connected in parallel as shown in figure. I is the total current. I1 is the current through R1. I2 is the current through R2. V is the potential difference. Hence, I will be equal to I1 plus I2. Call it as equation 1. Ohm's law general statement is V is equal to I into R. So here for the first current, V will be equal to I1 into R1. For the second current, V will be equal to I1 into R2. We are changing only the numbers. V equals I1 into R1, V equals I1 into R2. But since we need I here, bring this R1 down to the denominator. So what will we get? I1 is equal to V divided by R1. Okay, here I2, there's a mistake here, this is I2. Please change it up. I2 will be equal to V divided by R2. That is what is your formula. I'm repeating, V is equal to I1 into R1. I1 will be equal to V divided by R1. Same way, I2 will be equal to V divided by R2. Substitute it here. I will be equal to what is I1? V by R1. What is I2? V by R2. Addition symbol. What is common here? You can see V is going to be common. So when V is common, this will be equal to I equals, we'll remove V common and you can write it as 1 by R1 plus 1 by R2. Now this combination should be replaced by another single resistor, which is called as an equivalent resistor. A single resistor produces the same effect as produced by two or more resistors. So we call it as equivalent resistor. So when you apply this Ohm's law again, here the value for the resistance V is equal to I multiplied by Rp. So you can call this as equation 3. So when you are writing that equation 3, here you will get the formula as I equals, your common sign is going to be for the equation 2, you'll remove out V common. So you will get 1 divided by R1 plus, you have to write it as 1 divided by R2. So when you divide this equation, I will be your total current, R1 and R2 will be your current which is less. So here I will be equal to V divided by R1 plus V divided by R2. So when you take out V common, this equation will become 1 divided by R1 plus the V will be removed and you will write it as 1 divided by R2. Capital I will always denote your current. So after this step, V, if you remove out common, it's nothing but 1 by R1 plus 1 by R2. Compare this equation and equation 3. What is common? V and V. If you cancel them out, you will get, here I have written that step again, V by Rp will be equal to V into 1 by R1 plus 1 by R2. Cancel V on both sides. So you will get 1 by Rp equals 1 by R1 plus 1 by R2. So this is the effective capacitance of parallel combination. If you take LCM here, denominator will become R1 and R2. After your denominator becomes R1, R2, numerator will become R1 plus R2. So if you interchange this, you will get Rp is equal to R1, R2 divided by R1 plus R2. So I'm fastly brushing this up again. Circuit is clear for you. I will be equal to I1 plus I2. Apply Ohm's law. V equals I1 into R1. V equals I2 into R2. Change this to I2. Add using this formula. It will be V by R1 plus V by R2. Common factor here is V. Remove that outside. You will get 1 by R1 plus 1 by R2. Equivalent resistor, if you can change it to a single resistor which produces the same effect, then V will be equal to I into Rp. If you want I, write V here, bring down this Rp to the denominator. So from equations 2 and 3, I and I are same, so we cancel it up. you will write V by Rp is equal to V common 1 by R1 plus 1 by R2. Cancelling V on both the sides, 1 by Rp will be equal to 1 by R1 plus 1 by R2. This is the general formula. If we have to take reciprocal, R1, R2 will come in the denominator, R1 plus R2 will go up to the numerator. So this is the expression for parallel combination of resistances. You can try this experiment today at home and just see if you can do this small experiment at home. Just take a scale or a balloon. You blow a balloon, rub it a little and leave it to the wall. It will go and stick onto the wall. You can do the same thing with a pen or a scale. Rub it to your head and see if it can attract papers. Not just doing the experiment. What is the conclusion? You should be able to know. It is only because of the static charges which are present. Already charges are there. So when we rub them, they become activated and that is how they attract. So please go home and try this experiment and give the reason also. Reason is only because there are static charges which are getting attracted. I will unmute all your mics. Any doubts for today's class?